Hey guys, for today's reaction, we're going to be doing an esterification, which involves the combining of a carboxylic acid and an alcohol. The oxygen of the alcohol acts as a nucleophile and attacks the carbonyl carbon, which is the electrophilic site, in an acyl substitution reaction to create our ester product. One fun part about this experiment is that esters are actually sweet and fruity smelling, so this may be the only time the organic chemistry lab actually smells good. In this green reaction, we will be heating using a microwave for 3 minutes rather than the conventional method, which would be a reflux for more than 1 hour. To be a green experiment means that you have to fall under one of the 12 principles of green chemistry, which are shown here. Heating a reaction with the microwave falls under number 6, designed for energy efficiency, and certainly we are saving much time. You can get one of these green chemistry pocket guides from the American Chemical Society website. And in this experiment, you will be given an unknown alcohol and an unknown carboxylic acid for which you will form your new ester. And the ultimate goal of this experiment is to use the NMR and the IR of your ester to determine what your alcohol and acids were. And now for the experiment. In the microwave reaction vessel, place 4 milliliters of your unknown acid, 3.6 milliliters of your unknown alcohol, and 10 drops of concentrated sulfuric acid with 0.2 grams of silica beads with a stir bar.
Alright, so once you've put everything in your microwave vessel, you're going to come over here, make sure you have a stopper, and then your top, and you're going to finger tighten it first. And then you should bring it over to your professor. We'll go use the torque wrench to cue this clip, and then they'll pop it in the microwave.
Just like Brienne said, we're going to want to use the torque wrench on our sample vial until we hear the click, and then we're going to want to place that into our carousel, our sample carousel for the microwave. I'm putting this first vial in position 1. Now, a rule for the microwave is that you have at least 50 total milliliters every time you run the microwave. So we cannot just run a single reaction. So we have multiple prepared here. And we also want to make sure that we completely balance the carousel. So we have to make sure we position our vials in a way that they're balanced. Once all of our samples are loaded and the carousel is balanced, we will place the carousel topper and then push all of our pegs into the lock position to secure this cover on the carousel. The carousel can now be placed in the microwave, and we have to make sure that we monitor our main reaction, which is in sample chamber 1, and we're using this with the probe. So we insert the probe to the bottom of the tube, and we are good to go. After closing the door to the microwave, we will go to our menu screen and select Classic, and then you would go and select the ester reaction here. The method will be loaded, and then you will see the protocol put on the screen, and then you simply have to hit the start button. From here, the microwave does all the work. You can see the carousel rotating in one direction and then the other, all while the probe is monitoring our reaction in carousel position 1.
Okay, once your microwave vessel is done in the microwave, your professor should undo the cap, and then you'll come back over to your bench, and you'll undo the cap first. And then you'll use a pipette to take your liquid and put it into the suck funnel. Alright, once you've put your liquid from your microwave vessel in,
along with the diethyl ether,
you're going to do your first extraction. So you want to mix it together so that the reaction actually occurs, and make sure you release the gas every once in a while. And I would do this a few times. Each time you can get a little more aggressive with it. And then every time it asks for the organic layer in the slab, it's going to be your top layer.
The diethyl ether is on top and the water layer is on the bottom.
So for your first extraction, you're going to take out your aqueous layer. And then you're just going to set this aside for later.
Don't forget that organic layer needs to be poured out of the top of the funnel.
Okay, so after you've taken out your first organic layer, you're going to take the aqueous layer that you put aside and put it back into your suck funnel. And then you'll extract it with 5 milliliters of diethyl ether 2 more times. So after you've collected all your organic layers, you're going to pour it into a pre-weighed round bottom flask, and then you'll take it over to your rotovac, and then your professor should show you how to use the instrument from there.
Put your sample in your round bottom, and you use a keck clamp to clamp that on so it stays secure. The bath is filled with water, and your trap is filled with ice. Okay, so you turn the main power switch on in the back, and then there's a switch here too to turn on the water bath. Make sure that the vent is open here, and we'll turn on the vacuum. And now this is the knob that we're going to be able to use to control the vacuum. So you're going to close it, and you can hear that we now have a vacuum inside. So the vacuum inside added to the heat being added to the round bottom, and the ice is condensing, so you can see my solvent is dripping into the collection flask here, and you can see that it's disappearing from my round bottom here. Once all of your solvent is removed, you can stop the rotation. You can let the vacuum release. Then you're going to lift your sample up. You're going to turn the heating off. Take the keck clamp off. Remove your round bottom. And now you can weigh it for your final product. And your ester product is going to be an oily liquid. You'll take the mass of your final product to calculate your percent yield. You'll also be doing spectral analysis in terms of infrared spectroscopy and NMR spectroscopy on your final ester in effort to identify the unknown acid and alcohol.
And now it's safety with Jane. The unknown alcohols and the diethyl ether are flammable liquids and should not be used near open flames. Some of the unknown alcohols are also classified as irritants. Glacial acetic acid and sulfuric acids are strong acids. They are corrosive and can cause burns. This reaction should not be attempted in a sealed reaction vessel without temperature control. Caution: at the conclusion of the microwave heating, even with the proper cooling time, the vessels may still be hot to the touch.
Stay safe. A quick hint, right now the lab smells like bananas and pineapple and wood and butter. There you have it, esterification. Congratulations.